Hi, everyone. Welcome to another installment of our Cloud DevXChange meetups. Today, we have some great guests joining us who will do three very interesting talks. We have Elad joining us with the first talk that's called the Winglang programming language. Where we will see a fully working cloud app using Winglang. Winglang is a new programming language designed for the cloud that helps us unify infrastructure and application code into a single programming model, which is shipped with the local cloud simulator and the ability to compile your cloud application to multiple cloud providers. That is extraordinary, in my opinion. So I'm looking forward to learning more about that. Elad will also discuss some cloud fundamentals and the roadmap for his company, which was started after his impressive background of being the creator of AWS CDK and cdk. Elad is usually very into heavy coding presentations, so I hope we can keep up with that. Elad, would you like to say a few things?
Great to be here, Anka. Thanks for having us, and it's always fun to do stuff with you guys. Feels like a good energy, good match, and a lot of alignment on how we believe cloud development should look like. So super excited to be here.
Thank you for joining us. Our second talk will be done by our CTO, the CTO of LocalStack, Valdemar, who will be providing a hands-on introduction to LocalStack. And the session will cover multiple aspects of coding and showcasing common scenarios and use cases for cloud applications and debugging. Welcome, Valdemar. We're excited to have you.
Thanks so much for having us here, Anka, and moderating this live stream. So really looking forward to presenting some cool new stuff that we're working on with LocalStack. And as Elad mentioned, it's a very complementary and nice story, LocalStack and Winglang combined. So super excited to be here.
Yeah, and indeed it is. And our last speaker is Sebastian, who will be presenting the best of both worlds, LocalStack and Wing. And we will be seeing a Winglang application fully deployed on LocalStack. Sebastian will be doing a deep dive into cloud development, and we'll see how these two technologies interact with each other. Thank you for being here, Sebastian. We're excited for your presentation.
Yeah, thanks for having me. Pretty excited to be here, and yeah, looking forward to the other two talks. It'll be interesting.
Thank you. So if you have any questions, you can join the Slido and ask your questions there. And at the end of the sessions, we will be discussing them. Before we move on, we wanted to quickly remind you that LocalStack 2.3.0 is out with a few highlights, such as introducing the Event Bridge Scheduler, the Resource Access Manager. We have some new providers for the S3 and step function. We have a new Lambda data plane. We also have added Route 53 and SageMaker into the resource browser, and we have revamped the UI for Cloud Pods. We also have introduced an extensions library, and we have better and improved parity for LEB and RDS. So make sure to check it out. And once again, if you have questions or you want to discuss a topic, join the Slido and ask anything there. So without further ado, let's jump into our community talks with the Wing programming language by Elad. We can't hear you yet.
Okay. It's very tricky to use one screen. It's great to be here and collaborate with you guys on this. You know, as Wing is really young and early in the game, we feel like every opportunity we have to like introduce people to the ideas behind it, to get some feedback, and basically share our philosophy on like how we think cloud development should look like is blessed. And I think like with LocalStack, there's really an interesting connection in terms of like how we believe software development should work generally, and being able to actually stay in the flow and develop quickly. For me as a developer, is like one of the most important aspects of my environment. And I think both Wing and LocalStack share that idea. And I'm also really excited about this kind of connection between LocalStack and Winglang, which Sebastian is going to show. So I'm looking forward to checking that out as well. So basically, I think the first question that we get asked when we're talking about Wing is, why the hell the cloud needs a new programming language, or why the world even needs a new programming language? And I'm going to try to answer this question by showing you a little bit of what does it mean to use Winglang to write applications for the cloud, and emphasize some of the things that we've done with the language to reduce a lot of the barriers and the complexity that exists when building cloud applications for the cloud. I don't think that the only way to build cloud applications is using something like Winglang. And what we're actually planning is to release some of our SDK capabilities to other languages as well, in case people are interested in using those capabilities from different languages. But I think that the experience that we can get when we have full stack control over the full programming stack is it's pretty amazing, and I'm really excited about the DX that we're able to create with Winglang. There's a Q&A session at the end for I think 5 minutes, so feel free to like jump in and ask anything that you feel like I haven't answered. So basically, the reason we're building Winglang is that it's too hard to build stuff for the cloud. Everybody we talk to basically have a different view of the same major problems. One is that from one side, developers are disempowered, and on the other side, organizations are too slow. And you see all these things here, and I think that many of the people who are listening to this, these things resonate with them. The ability to actually iterate quickly and verify that what you've written is actually working and behaves the way you want as a developer. The need to be a DevOps expert in order to deliver to the cloud. That's a whole discipline of knowledge that most developers don't have, and frankly don't need to have, because their problem space is not the problem space of the infrastructure. Their problem space is the problem space of the business that they need to focus on. Testing is always coming up as a huge pain in cloud development, because you're relying on these cloud services and you have to orchestrate them together just in order to run a flow in your system. And so testing is like one of the most important things. And I think the general thing is that developers are saying that they can't stay in the flow. They constantly have to like step outside of their development flow and deploy or go to the console and check check the logs or understand what happens. And so this iteration cycle is the number one aspect that influences developer productivity and agility. And I think the cloud has almost completely broken that experience. And from the organization side, we're hearing problems like, we're locked into the cloud provider. We've been building for multiple years on a specific provider, and then we end up wanting to move away, and it's impossible at some point. We also hear a lot of conversations about undifferentiated investment. You see, like every organization has a platform team or a DevOps team, and they always end up doing the exact same thing across all organizations in the industry. It feels that it doesn't make any economic sense to have to replicate that work across the industry. We hear a lot of complaints around friction between developers and DevOps. platform teams, or I want a bucket and I have to go to my DevOps team and ask for a bucket. That doesn't make sense. A bucket is a fundamental building block of cloud applications. And the last thing that we're hearing a lot is that security and observability are too manual and too error prone because they're too manual. And so if my function needs, or my container needs to be able to access a certain resource, there's too many hands that this needs to go through in order to work. And we end up with a lot of non-least privilege permission models, a lot of problems downstream as systems get deployed. And then we realize, oh, damn, this IAM policy actually has more permissions that it needs to be, or doesn't have permissions to the things that it needs to access. And so looking at this space is like, okay, we need a new way to build stuff for the cloud. We need to rethink about how cloud development works, because all of these problems are fundamental. They're actually like, you can see them everywhere. So one of the observations that I came out of the CDK experience was that the cloud is not just infrastructure, and it's also not just application code. It's the combination of both application code and infrastructure. And there's no such thing as a cloud application that doesn't use any infrastructure, and there's also no such thing as something that application code that doesn't care about infrastructure completely. And I know that there are some solutions that are trying to completely remove the idea of needing cloud infrastructure to build applications on the cloud. But what we're trying to do is we're actually trying to create a model that allows developers to harness both application code and infrastructure to building their application, to delivering to the cloud. And I think that being able to actually express both application code and infrastructure in a single unified programming model is where we're coming from when we're thinking about Winglang. And so this slide, I actually try to it's ugly, I know. We need to work on that. But basically, what this slide is trying to say is that Winglang is a programming language. It's a platform-independent SDK, so it's basically a layer for using the cloud in a platform-independent way. It compiles to ready-to-deploy package of infrastructure as code configurations, such as Terraform, Pulumi, CloudFormation, Crossplane, whatever, and JavaScript. So basically, this infrastructure and code are combined together into a single deployable unit. And it also has a local simulator, which is in the Winglang architecture. It's basically just another platform that implements the various SDK capabilities, and we'll see it. We'll see it in a second. And so the output of Winglang is something that we can go and deploy on the cloud. And what we're doing with Wing Cloud at Wing Cloud is basically we're creating a platform for delivering Wing applications, whether they're written in Winglang or in the future written in other languages, delivering them to the cloud and keeping that experience at a high level. And I think that one of the things that we're hearing from current people who are using a Winglang is that once they compile to Winglang, once they compile to Terraform and JavaScript, now they have to become DevOps experts. Now they need to understand what it takes to deploy something to the cloud and operate it on the cloud. And what we're doing with Wing Cloud is basically closing the loop from the delivery perspective. And that's coming up. It's still not something that it's still something that we're working on. But in a way, this is kind of like our model. Okay, I guess I can talk as much as I want, but I think like writing some code is probably going to be the best way to understand to understand this story. And so let's just write some Wing application and see, and I'll talk a little bit into various things. So I mentioned, creating a bucket should be something that every developer can do very easily. And so let's start by creating a bucket. And so what I'm doing here, I have like my main file here, and I'm bringing this library called Cloud. We have a bunch of modules in this growing standard library that's shipped with Wing. And like every standard library, these are the foundational building blocks that you can use to build cloud applications. And it doesn't have a lot of resources right now. It basically has, I think, 10 resources at this point, maybe a little more. But this is growing all the time. I think we'll end up with about 20 resources that are at the foundation of the Wing ecosystem. And the reason I'm saying the foundation is because there's a whole open ecosystem that you can build on top of those resources and add other resources. And so actually, I think Sebastian's going to show some examples of how you can actually use any AWS resource from Wing, or any Terraform resource, or any CloudFormation resource, depending on the provisioning engine you're using. But the idea, again, like any standard library, is that there's these fundamental building blocks that that just exist. And so in the current state of our SDK, we have an API, we have a bucket, we have a distributed counter that you can use. We have this concept of a domain that you can associate with a website, for example. We have a queue, a schedule, basically a cron scheduler, secrets, long-running services, which are still being worked on, pub subtopics, and a static website. And so those are the building blocks that we have today. But as I said, we're working on more. And so let's start with the bucket, as I said. So basically, all you need to do in order to define a new bucket in Wing is to write new cloud bucket. And let's start by kind of like let's start by seeing what that looks like when I'm compiling this to AWS. Okay, so I'm going to compile this. And as I compile this, I actually specify the target platform. And you see that there's a bunch of standard built-in platforms that are shipped with Wing, like Terraform AWS, Terraform Azure, AWS CDK. SIM is the local simulator that we'll see in a second. And we're actually working on releasing capability to create custom platforms in Wing. So anybody can actually implement their platform. And a platform is basically something that adheres to a certain interface, and use this with the Wing compiler. And so this decoupling between application and platform is one of the key architectural tenets of the solution. Is the ability to actually write your code in a way that's independent of the platform implementation. But for the purposes of this demo, let's just compile it to AWS. And as soon as I compile it to AWS, now I can see that I have like target main AWS, TF AWS. And there's a Terraform file here, and with a bucket, which is to be expected. And everything else is just some boilerplate, some boilerplate stuff. And I can actually go and Terraform apply this to AWS and give me a bucket. But let's move on and see how this evolves. The development workflow that we are encouraging with Wing is actually not to go and deploy everything to the cloud every time you change something, but use what we call the Wing simulator platform, which is basically the default platform for Wing. And if I call Wingit, it'll basically compile my application to the simulator platform, and it'll pop up a web application that shows me my system as I develop it. And as you can see, as expected, I can basically see a bucket here. I can upload and download files and interact with this bucket as a resource. It's interacting with the bucket that's running locally on the simulator. So I can actually really quickly create, 2 buckets, for example. And as soon as I say this, the simulator hot reloaded this and updated the diagram, and I can continue to interact with that. So this is basically the flow that we're trying to create for developers, which is, to me as a developer, this is what I would expect, right? Like I want to write code, I want to just play with it and see that it's doing what I expect it to do. And so the next thing I want to show you is a resource called the function. And the function is basically something that represents a short-lived compute workload. Simple, it goes to AWS Lambda, it goes to Azure Functions when you're compiling to Azure. And so it basically is our version of a platform as a service compute primitive. And the first parameter of a function is what we call an in-flight closure. And so an in-flight closure is the same as any code block that executes, any closure that executes code, but it has this unique modifier called in-flight. And in a way, in-flights are, sorry, I don't know why I'm jumping. In a way, in-flights are basically the only interesting thing about Wing as a new language. And the idea of in-flight is basically to say that the thing that's running inside this code block is going to run on the cloud. And so this definition of the bucket and the definition of the function are what we call pre-flight objects. And those represent the infrastructure. Those represent the architecture of my application. And the thing that's running inside my Lambda function in this case is expressed through this idea of an in-flight closure. And so by supplying that in-flight closure here, I can go and I can run this function, and I can see this log emitted from my function. And I can also compile this to AWS. So I can go and I can compile this to AWS. And if I look at the Terraform now, it's a bit more involved. It has a log group specified, an IAM role and IAM policy for my Lambda functions, and the Lambda function itself, and a bucket for the code, and it uploads the bucket to the code, and it creates an archive that can go into the code, that basically goes into the Lambda function, contains all the so it takes care of all the details of implementing this to a specific cloud provider. This is basically the responsibilities of the platform. So in this case, TFA. Okay, well let's make this a little bit more interesting. Let's say I want my function to interact with a bucket, and this is where this idea of in-flights becomes really interesting, because if I want to write let's call it B1. If I want to write something to the bucket, then my intuitive interaction as a developer would be to do B1 dot and call some API on the bucket. And as you can see, I have this set of method calls that I can do against this abstract concept called the bucket. And I think it's important to mention that this is not the AWS S3 API. You use the same API for any bucket that anything that implements this interface at the platform level, which is not a very popular. It's not a super popular opinion, right? We actually do believe that it's possible to create this abstract layer from an application perspective to use the cloud, and that's what we're working on with the Wing Cloud library and the SDK. Now, the interesting thing is you can see this list of APIs that I can interact with at runtime, but if I actually do this, I see a different set of APIs. And so this is the pre-flight API of the same object. And this API is basically responsible for configuring the bucket notifications, for example, which is basically part of the infrastructure configuration. It's not part of my runtime. And so this ability to actually express the idea of a pre-flight API and an in-flight API is at the foundation of Wing. And that's one of the main reasons we needed a new programming language, is because in Wing, there's the concept of pre-flight and in-flight is fundamental to how the compiler works. Okay, let's, I'm sure I'm taking too long. So I'm just going to write something to the bucket. And so as soon as I did this, and I save this, you see that now my function has this line that connects to the bucket. And this line is pretty interesting. First of all, if I click on it, I can see that it's performing a put operation on the bucket. So there's some visibility that this console experience received by using Wing in that sense. And what happens is the compiler actually sees the interaction between in-flight code and pre-flight objects. And so this put operation is information the compiler has. And the reason it's interesting for cloud development is that as soon as I compile this to AWS and I look at the Terraform here, I can see that I have my IAM role policy, and it actually has minimal permissions on that specific resource, because the compiler understands that I'm doing a put operation on the bucket. And if I add another operation on the bucket and I compile this, now you see that I have additional actions on that IAM policy. And so this is an example of how we can leverage the ability that we have visibility across infrastructure and application code to reduce a lot of the cognitive load and the problems that we talked about at the beginning of the talk. Okay, Let's continue quickly with some other capabilities, and just to give you an example, a sense of what does it mean to use Wing as a programming language for the cloud. And so what we want to do, let's say we want to create a bucket. One of our favorite examples is every time you upload something to the bucket, it'll write it to a different bucket with uppercase, so some kind of a processing queue. And then every time a new object comes in, it'll process it and write it to an output. So that's a classic kind of pattern for data processing on the cloud. And so let's do it as like I would do it as an object-oriented designer, right? So I'm going to create sort of like a bucket uppercaser. So I'm just going to create a new class, and that new class would take a source bucket and a destination bucket. And then what it does is basically every time a file is created on the source bucket, so that basically takes a key. Let's make it interesting and put it in the queue, in a cloud queue. So let's say it's something that takes a long time to process, and I want to be able to control the flow. And so basically, what I'm going to do is I'm just going to push the key to the queue. So that's the first part. Processor. Now, nothing happened here because I haven't created an instance of this bucket uppercaser. I'm just going to create an instance, and it takes an input bucket. Let's change this guy to input. And I'm going to create another one called output. I'm going to remove this for now. Okay, so this is starting to get interesting. I have like my input bucket here, and you see the event handler is some kind of leaking out to me, and that's actually something that we're trying to figure out the right UX for. How deep do we need to show for every resource, right? And so we have the input bucket and the output bucket here, and we have like a little bucket uppercaser, and we can see the push operation that this handler is doing. Obviously, it's still not doing anything here because we haven't subscribed to the queue yet. And so the second thing I do, I'm going to create a consumer here, and so this is getting the key, and I'm just going to do, I guess something like that. This is called uppercase instead of two uppercase. Copilot is starting to be helpful. And so as soon as I save this, you can see that now I have this little event handler here, and that event handler is basically pushing the message to the output. Oh, sorry, this guy. The consumer here is putting the file into the output. And let's create a function to test this. Let's call it start flow. Start here. And what I'm going to do here, so now I have like a little start here function, and I'm going to put something here. And I'm going to click start here. And if I look at the output, you can see that I have DevXChange uppercased on the output bucket. I guess we can stop here. I had 3 million other things to show you, but we're running out of time, and I want to make sure that everybody has the opportunity to finish their presentations. Let me just finish with some time for questions if anybody has any. And give me a second. Go ahead. There we go.
Hi. That was impressive. Wow.
Do you mind?
Yeah,
Just
I'm lost for words. Sorry.
One more slide, if you do you mind adding my deck again? I have just a few more things that I wanted to share about like our roadmap, and then we can. Sure. Cool. Thanks. So yeah, just things that are on our plate, and some of them are already pretty advanced, and we're working on them. So again, stabilizing the language itself and the specifications of the SDK and which resources we support, and the APIs and patterns, and that's ongoing work. But I feel like we're getting to a point where we feel more and more confident that we've got a first kind of like big release of the version of the language and the SDK. Our VS Code extension is already functioning pretty well. Like, as you can see, there's a lot going on behind the scenes in order to like provide that amazing developer experience. We're working on being much more automatic and intentional about provider coverage across the various cloud providers and platforms, and so we have this matrix that shows you all everything that's supported or not supported yet. And, if you want to help, you can pick items from there. We have support for websites, and we have initial support for web applications like React applications and hopefully some Next.js applications. And so being able to actually create static websites with Wing and integrate them with the backend seamlessly is going to be, I think, a really cool thing and really powerful capability. We're hopefully going to ship container support and Kubernetes support soon. That's something that I've been working on a side library, actually, because we already have support for libraries, and so you can actually like deliver stuff like that outside of the main SDK and then mature it. More DX improvements for Wing. That's actually supposed to be Wing console, the console experience in this graphical UI. And the last thing is library support and custom platforms. And so those are things that are in the pipeline, and hopefully you'll see them come up soon. Cool, that's it. Now I'm done.
Thank you so much. That's amazing, and it's so easy. And being able to see your infrastructure is really, really a nice feature. We do have some questions. Should I read them out to you, or? Oh, there we go. Why compile to JavaScript? Will we also see other language targets in the future?
So hopefully, yes. We would love to see other language targets. It's interesting to think about pre-flight and in-flight separately in that sense. Pre-flight code is basically executed as part of the compiler. When you're compiling your code, it executes the pre-flight code, which produces the outputs. This synthesizes the CloudFormation or the Terraform or whatever. And the in-flight code is what's going to run on the cloud. And we've started with JavaScript because we're good. We know JavaScript very well, and we love the ecosystem. So one of the benefits of doing that is that you can actually use any NPM module with Wing as an external module, and so you can really easily get started from a JavaScript Node.js background. But I totally think that there's value in being able to target other ecosystems, like even the native ecosystems or the WebAssembly ecosystems or Python, and there's nothing in our compiler that's like strictly constrained to JavaScript in that sense. So being able to actually add different backends is definitely something that I want to see in the future.
Awesome. This is pretty cool. Are there also resources for GCP?
Yes, there are. If you want to share my screen for real quick, this is basically our compatibility matrix for the built-in modules. Built-in platforms. So SIM, the TF AWS, TF Azure, TF GCP. And so you see these things are starting to be filled up, but there's also a lot of missing pieces. And contributions are welcome. It's an open source project, and we're actually getting a lot of contributions from the community around these areas. I don't know. Wait, I shared a different. Give me a second. This one. There we go. So in the Winglang docs, you should be able to find a compatibility matrix under the standard library section, and that's where we're tracking support for basically every method across every platform. And so let us know if anything is missing. As you can see, there's a bunch of little issues here, so you can like click on that issue and +1 it if you feel like something is needed in any one of those, and obviously contributions, as I said. Any other questions?
Yes, somebody asked about Pulumi, but I think you mentioned that.
So we don't have any Pulumi platform yet, but there's nothing in the architecture that prevents anyone from creating a Pulumi platform that basically implements the various SDK resources with Pulumi, right? It could be Pulumi AWS, Pulumi GCP, right, or whatever. What we are doing is we are opening up for custom platforms. And so currently you don't have the ability to completely implement your own platform. And what we're adding support for is just bring your own platform kind of API. So you can compile your code and say, I want to use some NPM library as a Wing platform. And that's going to give people the ability to actually just implement whatever platform they want.
Nice, that sounds very convenient. Great. So if nobody else has anything to say, which is you, the only person here, let's move on to Valdemar's talk.
Cool.
Awesome, that was fantastic. Thanks so much, Elad, for sharing this. I love the Wing console and like the quick feedback cycles you get with the development. So really, kudos for showing that. So let me. I'll try to be more or less brief in the sense that I want to make sure we also see the Sebastian's demo at the end. So let me just switch over to my slides here. Okay, cool. So what I would like to cover, just give a quick overview of LocalStack, show a couple of demos, and dive into some of the features. Presumably, some folks on the call will be familiar with the tool in general, but also going to give like a short just background. So agenda, I want to cover just a short intro of LocalStack, then diving into some serverless application development, showcase briefly how we can do things like Lambda hot reloading, hot swapping, and then talk briefly about some more advanced features and for example, Cloud Pods, which is one of the features we're quite excited about in LocalStack extensions as well. So just very briefly, the context of where we operate in, and Elad already touched upon some of the challenges that we see in the cloud today. You have relatively slow feedback loops when it comes to deploying your changes to the cloud for every single change you make. Remote debuggability also becomes a challenge. Thinking about things like maybe you have a CI/CD process, and some of your builds is failing in the CI pipeline. It can be hard to replicate the state onto your local machine and figure out what's going on. And then also managing dev infra, right? So we see a lot of companies out there who are just managing a lot of, let's say, automation around cleanups of cloud environments, and there's a whole lot of moving parts just going on just to make sure that these sandbox accounts on the real cloud are not getting out of hand and out of control from a cost perspective. So, and if you just generally, this slide may be a bit overloaded, but just bear with me for a second. So if you think about general development and test approaches for cloud applications, we see the different sort of parts of your development, right? So you have your IDE, then there's some application code, and then the code it gets executed somewhere, right? So, and the default model that if you just develop against the real AWS cloud, for example, your IDE and code is local, and the code is executed remotely, and you have things like the application logs to gain insights. So this is kind of the default mode generally promoted by the cloud providers. There's a middle tier here where in order to bring your resources closer to home, closer to localhost, there is some cloud proxy providers such as SST or Lightrun, to name just two, and they are basically giving you the local impression of a local execution, but in fact the execution is still happening in the remote environment, and you have some proxying mechanisms. The other thing, and sort of at the other end of the spectrum, is local emulation, or as we saw, local simulation, also in the case of Winglang, where literally you sort of try to pack everything onto your local machine. And then it's obviously not a replacement for testing in a staging environment. You would still do like pre-production staging testing, but at least you can iterate much more quickly on having all these moving parts on your local machine. Okay. Right. So just again, in a nutshell, so the approach that we take at LocalStack to this problem is to really provide a local emulator for cloud applications, for cloud APIs. So currently we provide something like 75 plus APIs. So this ranges from compute, APIs, databases, messaging, lots of different services. And we'll see some of those in the demo afterwards as well. It ships as a Docker image, so you can easily spin it up on your local machine or in a CI environment, and it's relatively cross-platform compatible through the fact that it's just a Docker image. All right. So again, without going into too much sort of details, let's just dive into a short demo. So what we want to show is, and it has maybe some similarities to what Elad was showing before. We're not going to do uppercasing of files, but what we're going to do is we're going to do a little serverless image resize application. So basically, a application that consists of S3 buckets, Lambda functions, some SSM parameter stores, and a few other parts to upload images to a web UI and then get them resized to thumbnails, basically in an asynchronous processing manner. You can actually find this also in our docs. We have a section of our docs that is called the Developer Hub, and you can also find the link to that application there as well. So let me quickly switch over here to my dev environment. So first of all, there's various ways to start up LocalStack. Typically, we promote the use of the command line interface, the CLI. But what I'm going to do this time is I'm going to use our LocalStack Docker extension, which is a nice way to start up LocalStack. You can actually install this from the Docker marketplace, and it shows up as this item here on the left-hand side. I've created just a test configuration here with some basic environment variables, and I'm now starting up LocalStack, and you can see all the services that are now available and up and running. We can take a look at the logs here. At the end of the logs, it's just telling us ready, so we can now use the system to run to deploy this application. In order to do that, I will switch over to my terminal. So I have a terminal window here where I'm basically, I have this project checked out. And what I'm going to do now is basically just run this bin deploy script. For the purpose of for time constraints, I'm not going to go into too much detail, but just let's take a quick look at what this script is actually doing here. So basically, it has a sequence of AWS local commands, which is our small wrapper script for the AWS CLI. And basically, it creates S3 buckets. Initially, it creates some SSM parameters, topics, subscribe to SNS topics. Then it creates the main Lambda functions. We have two. One is a pre-signed Lambda for creating S3 pre-signed URLs to upload images to the bucket. And then the other Lambda is called list. It basically just lists the existing images that we have currently stored in our S3 bucket. And you can see there's actually some more like a switch going on here. If we're on Darwin on macOS, we actually need to compile or build the Lambda function with a special Python image here, because actually what this Lambda function uses internally is a library called Pillow, which does the transformation of the images, and this requires a certain version of the libraries and also the exact version of the architecture of the CPU architecture. And then the rest is just, again, functions and some bucket configurations. So this is really, you could also define this in a Terraform script, but in this case, we just manually deployed everything with AWS Local. All right, so now it tells us here that this deployment is finished. So let me just copy paste this URL here, go over to my browser. And what we can do now is we get this simple user interface, which is just I believe a jQuery material UI kind of interface. Again, this is also part of the demo app. And the first thing we do here is we click load the Lambda function URLs. So in LocalStack, we have a way to create these local domain names, which resembles in some way what you would get in the real cloud environment, but the sort of the suffix of the domain name is always localhost.localstack.cloud, and then it's running on this port 4566. So under these two endpoint URLs, we can now the web UI can now call these Lambda functions, and right here we have this form where we can now actually select some images. So I selected obviously the one from our meetup here, and I'm just hitting upload. And so let's again switch over to the terminal real quick. And what happened here is that I do a Docker PS. And this is something that some of you may be familiar with. Obviously, it spins up these Lambda Docker containers for the resize Lambda and for the pre-sign and for the list as well, I believe. So now we have these containers running, and they're now sort of serving the requests. And now I can refresh this page, and what should then happen is that we actually see this file listed down here with the original size and the resized thumbnail. So again, relatively nice, simple demo application, but it kind of nicely shows you how different pieces are fitting together. And again, at no point do we ever talk to the real cloud environment. It was all just happening on the local machine. Now, this is nice, right? But now you might think, okay, what's next here, right? So what's the broader story behind this? So as what we would like to do as a next step, let's assume we want to actually make changes to our Lambda functions, right? So this is a classical use case for also what Elad was showing before. You want to really quickly iterate on some of the functionality in your application, and we have this mechanism that we call Lambda hot reloading. The way it basically works is we have a special sort of bucket name that is just called hot reload. And if you deploy your Lambda function under this bucket name, you can specify a local path that points to the path in your host environment with the Lambda function, and then we can just iterate quickly, make changes without having to redeploy the function itself. So let me just quickly do this here. So I'll go back to I have this in my history, I think. So I'm just going to do this Lambda update function code. And I'm now basically with this command enabling the hot reloading. So from now on, any change I make to the Lambda will be automatically reflected in the changes. All right, so now let's take a look at the actual Lambda and make some changes. For that, I'm moving to my PyCharm IDE here. And I'll take a look at our Lambda function. So this is in this case, it's written in Python. It has this handler here. And this is the place where we actually do the listing of all the images. And let's assume we want to change this logic here now and say, we want to return some static size here, right? So instead of returning the actual object size, I'm just going to return a sort of a crafted up or hard-coded value, 10,000 bytes, and just store this file. So I'm not going to do a redeploy, but just going back to the web UI here, refreshing the page, it's calling the Lambda function, and we can see that we have this hard-coded value, 10,000. Maybe then we realize, no, maybe it's some other value, 2,000 or 20,000, refresh again. Obviously, those are really dummy changes, but just to show you kind of how to make changes, refresh, and automatically see the changes reflected in the outcome, in the result. So this is really what we refer to as Lambda hot reloading, and we have a bunch of cool sort of work streams where we're now also integrating this into IDEs. So there's a plugin for Visual Studio Code, for example. If you want to check this out, we have this, I believe, even it's in the Microsoft App Store, and just more integrations even with your IDEs to really quickly iterate on your Lambda functions this way. Okay, nice. So this is kind of just briefly showcasing our Lambda development and debugging and hot reloading mechanism. Now the other thing, as briefly mentioned before, we were using AWS Local in this sample, which is very basic and crude approach to create resources, but there's also various integrations that you can use in LocalStack. So I think interesting maybe is this top right corner here where we have infrastructure as code tools. Forgive me, Elad, if Wing is not really an infrastructure as code tool. I think you might have some more specialized definitions there, but I think it fits in quite nicely here alongside things like Terraform, Pulumi, CDK, and so on. So you can use these tools natively against LocalStack and just bring literally your production Terraform scripts, for example, and deploy them against LocalStack in a fairly easy manner. And then the same goes for different CI/CD systems, application development frameworks. So we have, for example, serverless is a pretty popular framework a lot of users are using, test containers, and a bunch of others. So this is really a growing ecosystem, and you can find more in our docs as well. Okay, so now switching gears a bit and maybe just to touch upon one or two additional, bit more advanced topics. So one of the features that we're quite excited about is cloud pods. So essentially, when it comes to state management in LocalStack, the the container is ephemeral. So when we restart the container, the state is sort of flushed out. So you always get like a fresh instance. And that is, works for a lot of use cases, but then there's also maybe the need for some persistent state, right? And we offer two modes of persistence. One is the regular or snapshot-based persistence, as we call it. Basically every change in your container gets persisted to disk, and then when you restart, it comes back up again. And the other mechanism is what we call cloud pods, and this is more of a point-in-time snapshot where you in the running container you can actually say, I want to save the state right now, and then later on be able to inject it back in into a fresh instance. So it's a fairly nimble and flexible way to deal with state. And I just want to briefly showcase how this works. Essentially, the way how we expose cloud pods to the users is for the most part with the CLI, with the command line interface. There's also a web user interface client if you're interested in checking that out. Maybe we can just briefly switch over there. So if you go to app.localstack.cloud, this is our web app, where you also find a lot of different functionalities for browsing the state of your resource, for example. So we have this feature called a resource browser. Actually, let's maybe take a quick look at that. We can inspect the state of our S3 buckets that were, we can see the thumbnails that was created before. So there's a bunch of different views here you can leverage. Let's go to SSM Systems Manager, for example. So that is the SSM parameter that stores which bucket is going to be used for the images and the resized images. So just an additional way to interact in a graphical manner with the instance. And bear in mind that this browser is literally connecting to localhost to the local instance. It's not going out anywhere to the real cloud. It's just a local interaction. And as briefly mentioned before, cloud pods are also exposed in this UI. So, for example, here we see the list of all our test pods that we've created within our own internal organization. And I want to just briefly showcase how this could now work for the application that is currently still running in my container, right? So we already have some state in there. So what I'm going to do now is we're going to run the command local-stack pod save, and then just the name of a pod. Let's just call it image resizer test. What's now happening is basically the CLI pulls the state out of LocalStack, pushes it to our managed storage. So we provide a managed storage for that, and it shows you some basic information like which services are contained in this cloud pod, which version. So I've done a couple of tests already before our demo. Each save operation creates a new version, and you can also roll back to previous versions. And we've now basically saved the state of this, right? Now, what I'm going to do next, so now that we've saved the state as a cloud pod, let's stop the container here. So just again, using our nifty UI here, then start again. And as mentioned before, we should now have an empty state. So if I do an S3LS here, for example, or if I do an, if I list what else do we have before? Lambda, list functions. Oops, then there's nothing in there, right? So because that's kind of expected. And now in order to get the state back in, we can do the reverse operation, which is called load. So instead of doing the save, we now actually do the, oops, go here. So I'm just going to do a pod load with the same name, and then it basically fetches the state that we previously stored from the platform and then injects it into the instance. And then we have the same state loaded back in. So I can do now a list the functions here. I can do an ls on the bucket from before. Local 3ls, and we see the same state is here again, and it's even down to the level of going back to refreshing the page here, and then if I refresh, we literally have the same state. Even like the image that we previously uploaded, which is in a S3 bucket, that's also restored, right? So it's literally the same. Like it's both infra plus application code plus the state is all contained in the cloud pod, and you inject it in a very easy manner. Yeah, so that's essentially the sort of the story of cloud pods and how you can use it for, you can think about various use cases to deal with state. If you want to pre-seed your CI environment, for example, with some state, or you want to collaborate with your team members, that is a feature that we're quite excited about. And there's one more feature that I would like to touch upon, which is LocalStack extensions. So I think Anka already briefly mentioned it in the in the intro. We really doubled down in the last couple of months on providing a really nice user experience and developer experience for extensions. So extensions is basically a way to plug in new functionality into LocalStack, and this can range from additional service emulators. If you want to have something like a Stripe emulator, or Miniflare is a Cloudflare emulator. We're partnering up with the Cloudflare team there. So additional emulators is one part, but then also some advanced features like chaos engineering, for example, which we're increasingly building out. So when we say chaos engineering, it's injecting things like latencies into your application or certain error conditions, and then really testing your application for these and testing the resilience of your application against these errors and issues. And we'd really encourage you to take a look, develop your own extension. We'll be happy to provide guidance if you want to give it a try. And it's also, again, exposed in the UI directly. So we've created this nice nifty view here where you can actually from the UI directly inject some of these extensions directly into your instance. You see, it's not like super many instances in here, but we're definitely bootstrapping them and adding more as we go. And we'd also love to hear from you what you would see as a useful extension for your local development and testing. And thinking about it, I think we should definitely also have like some sort of a Winglang extension here. But maybe let's follow up on that separately, Elad and team. Okay. Yeah, so coming back, and this is basically already a wrap. So I hope that was kind of useful, giving you a bit of an overview of LocalStack, some of the basics, how to run it in Docker, do things like Lambda hot reloading, use Cloud Pods for persistence management, and then again venturing in these extensions, which we're currently really pushing and doubling down on. So some of the features in the pipeline already mentioned. So extensions, definitely we see a lot of potential there to enable more advanced use cases, things that you really cannot easily test in a real cloud environment. And again, fault injection is a very good example. We're also experimenting with what we call hybrid scenarios, where part of your stack may be running locally, but some resources are in the real cloud, and you actually want to leverage them. And there's some extensions that make it very easy to integrate remote resources into your local environment. Chaos engineering, also briefly touched upon that already. Ephemeral cloud sandboxes, it's something we haven't officially put out yet. We're a bit more in the process of experimenting with those, but it's almost a bit like going full circle, like coming from a local emulator to a hosted sandbox instance. But this is just coming out of one of the key use cases of being able to show like preview environments of your application, for example, right? If you want to quickly deploy a change, show what it looks like, you can then easily just get an endpoint URL that you can share with somebody on your team, and you have these sandboxes available. And we're also doubling down on like even deeper integration with Cloud Pods, Stack Insights into CI builds. We really see a lot of potential for having even better debuggability and observability in the CI pipelines. Okay, so with that, also would love to just give a shout out to the team for creating a lot of great samples in the developer hub. So please go check it out, docs.localstack.cloud. You'll find a lot of cool samples, including the one that I just shared today. And I think with that, I'll be happy to take some questions, and I'm very much looking forward to Sebastian's demo as well.
Wow, thank you, Valdemar. I'm so used to LocalStack by now that I keep forgetting what a little lightning in an image it is. So we have a few questions. The classic, what prevents LocalStack to go into Azure and GCP as well? Limitation of these cloud providers?
Yeah, so definitely for the most part, just team size and focus. So we've kind of decided a bit to go deep in sort of depth first in that sense, really exploring the AWS space in full detail. We have a lot of work around parity, making sure that we really have the strongest high fidelity emulator out there. Having said that, though, it's certainly something we constantly have in the back of our minds, and plans are also becoming a bit more concrete now when it comes to at least the Azure roadmap. So stay tuned. I think next year there's going to be quite some traction there in this space as well.
That sounds exciting. Looking forward. Is it correct to call Cloud Pods as Git for cloud infra?
That is a very, I love the analogy. And in fact, in an early incarnation of CloudPods, we had literally commands like commit and push. We sort of went away a bit from this terminology because it introduced additional complexity, but it's very similar from the standpoint of being able to snapshot the states, being able to version things over time. What we'll probably, I'm not sure if we're going to have like the full branching model of Git in CloudPods. What we do have though is a way to merge multiple pods together into a single combined state. So that's also something that I think is pretty exciting. So yeah, I think that analogy is really very much spot on, and I like it. And also one more point to add here. So the default storage that I showed today is against our platform, but we also offer CloudPod remotes. So it's similar to Git, where you can point at different remotes. In CloudPods, you can also sort of point it at alternative storage backends. You can even store to a Docker Hub or store to an FTP server or something. So there's definitely ways to provide remote implementations.
Can I use AWS CDK to deploy my infrastructure and app code to LocalStack?
Yes, absolutely. We love the CDK, and we have in LocalStack a CloudFormation implementation. Like we have our own engine because CDK basically transpiles to CloudFormation, and we interpret these CloudFormation stacks and deploy all the resources. And there is this small wrapper script called cdk-local, which we provide that makes it super easy to just do a CDK local deploy, basically. So yeah, 100%. Terraform, CDK, those are really well supported in LocalStack.
That's great. Thank you for your answers, and thank you for the wonderful presentation. I think it's time to move on to see the best of both worlds in a talk about LocalStack and Wing, and how you can deploy Winglang apps on LocalStack.
Yes, cool, thank you. Yeah, pretty amazing stuff. Really likes this cloud pods thingy to persist state, and that sounds pretty amazing.
Yeah.
Let me share my screen. Just go with the full screen. And here we go. Right. So yeah, so we saw like Winglang already, like in depth. We saw like a whirlwind tour through LocalStack, and as already mentioned, so like I'm going to show like how to bring these two worlds together, and we're doing this by an example, like the voting apps. This was built by one of the core contributors to Winglang as a little example. Since it has like a nice interface, and it's also using actually native AWS infrastructure. And so like the end result is sort of like this, right? So like a ELO algorithm ranking for some food items, essentially, right? So you can vote, and it's going to be persisted. There's like a little leaderboard, and that's the actual live deployed to CloudFront version here. You can see the leaderboard, and so that's the rough scope what we are talking about here, right? And as part of this, I actually used like a LocalStack for the first time, and so I had to go through the entire setup. So I just went with the CLI version, like the local version, like did like the little setup tour to get the stuff up and running locally, and so like I think the docs are mentioning like that there's like a Terraform wrapper TF local. We already saw the AWS local wrapper around the AWS CLI, and I didn't really want to use this, so I went with like custom implementation. But before we dive into this, so that's like the local version, or like the checked out Git version of this. And let's just have a brief look into like how this looks in the simulator. And I don't believe it's actually working, but while we can see the diagram here, it's not really working locally. Actually, I'm not really sure. It might be like a bug in Winglang, but not really sure. But this is like on a high level, that's like there's an API, there's like some sort of table, there's like some custom table. We see the DynamoDB table sim, which is not what we're gonna be using, right? So it's like a bit more meat to this application than what Elad was showing in his demo application there. And let's just without really going into detail here, just really you see it's like a bunch of Wing code, custom Wing code, using packages from npm, like the cdk-tf is I think shipped by default, but in order to use the DynamoDB version, we're using an external JavaScript file here, which we bring in, and this is using like the client, right? The AWS SDK client for DynamoDB. So some custom implementations here, which are going to be pulled in for the Wing DynamoDB file here, and it's doing some magic you don't really have to go and understand here. One important aspect, though, is this one here, right? So we are using the AWS provider, we're referencing like a DynamoDB table, and this could be anything in the end. In this case, it's like DynamoDB. It could be like step functions. It could be, I don't know, some RDS. It doesn't really matter in the end, I think. But just an example, and since it was built that way. So by default, if you would want to deploy this to AWS, we would go and compile this to the target AWS. And that's really all it would take to compile it down to Terraform and JavaScript, which then would look like this one here, right? So like a bunch of Terraform configuration in the JSON format, like the little application, the API handlers here, which are just like, I don't know, some archived JavaScript files. And so I can see we could just move into this directory and go ahead and just deploy this via Terraform. If you had AWS credentials, this would potentially work. But it takes time. There's like some CloudFront distribution involved, and like there's probably some resources which we want to use which are not part of the Wing SDK. So let's use LocalStack. And so besides from using something like tf-local, which I don't really have installed anyway, I just looked at the code, what they're doing, and it's mostly configuring, I think, the Terraform endpoints. And there's like a concept in Winglang of plugins, which allows to use hooks, which are, let's have a look here, the LocalStack plugins. So we are using compilation hooks in Winglang. So like essentially lifecycle hooks. So presync, postsync, and validate. So with presync, we can actually like hook into the configuration before it's like compiled down to Terraform. Postsync is like the step afterwards. And in these two hooks, we can still change the configuration. And in the validation hook, we only can validate, right? You can only say, okay, there's something which is wrong. We don't really want to allow this for whatever reason, and exit with an error, for example, right? Which is not really what we want to do here. So what we want to do here is we want to change the AWS provider, right? And this is mostly taken from the tf-local implementation. So just configure like a bunch of endpoints for the AWS provider, and essentially pointed towards like the locally running localhost instance. So this went pretty well. So it had some DNS issues. It's always DNS problems, right? But in this case, I had like a bit of struggle with this one here, but this was solved by just switching my DNS to the Google DNS. And like another point which needed some adjustments where I'm using like another hook is I needed to somehow make the LocalStack instance available for the AWS DynamoDB client. And according to the AWS documentation, it's supposed to work like this, that you can just provide like an environment variable with the correct endpoint you want to target it, and then it should be picked up automatically. At least that's what I found in the documentation. It didn't really work. So what this is doing here, so before it's actually compiled down to Terraform, it's implementing like an aspect, like a visitor pattern, and it's visiting all the different nodes from the application, finding all the Lambda functions, and then the parent of that to actually inject the environment variables here for each Lambda function which is there. So in theory, this should have been working, but it didn't really. So that's why eventually I was just, okay, I probably have to just change it here and pass it in explicitly. There could be of course, like a check, okay, are we running locally or not? In this case, didn't really bother doing this. So, and I think that's pretty much really all it was in the end. And so for the compile, we still want to compile down to AWS, but this time we want to use a plugin, which was the plugin LocalStack, which is like a JavaScript file. And this is going to inject this configuration. And we can verify that it actually was doing this. Somewhere here, you see it rendered out like this. And I don't think there are probably more endpoints, but it's like sufficient for this example. And then we can actually go there, run init once. I have local-stack running already, so it's like just the CLI version of this. And then, oops. You can see it's going to hopefully starting to, you see some logs from local-stack here, and it's going to create all the different, yes, it's going to create the infrastructure here. And in a few seconds, we should actually be able to see the same version which we saw already from the production version. We should see the same version running locally in local-stack. For some reason, the distribution still takes a few seconds. Not really sure why that is. But that's probably a problem shared between local-stack and AWS as well. But it's way faster than AWS. But it still takes time. And I think it should be there any moment. Then we get the URLs, and then we can actually see what's going on. Dim, 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 dim. Dim, dim, dim. And there we go. So we have the API URL, which is serving the request from the website, and then we have the actual website running here, and we see, like everything is working similar. We are working on the local version of this, and it's actually pretty cool to see, like everything is still running locally, even though we are using maybe resources which are not part of the Wing SDK. So, and that's pretty much already it, I think. Was there anything else? No, I think that's pretty much already it. Oops. So yeah, like that was my short and sweet demo about Winglang meets local-stack.
That was awesome. I love it when stuff just works on local-stack. I'm so surprised.
Yes. Again, like it was like one or two little changes required, but overall it was really quite smooth. Yeah.
Yeah. Should we take some questions? I see no new questions, but there are some from behind. Yes. If a company is using modules approach or stacks, how to split the generated Terraform code? In all fairness, it popped up during the first talk.
What are they referring to by modules?
I think the can you hear me?
Yes.
I think the question was that when you're compiling Wing applications and it produces a Terraform file, if I'm as a company, I use modules, for example, to codify some policy around how buckets are created or how encryption is like across multiple applications.
Like Terraform modules.
Yeah, Terraform modules. And I think the other side of that question is maybe, can I use Terraform modules in Wing? So happy to try and answer both. I think the second one is easy. Yes, you can use any Terraform module in Wing. Thanks to Sebastian's work on CDK for Terraform. I don't know if that was mentioned, but Sebastian is the creator of CDK for Terraform. So Wing is built, when you're compiling to Terraform, Wing uses CDK for Terraform under the hood. And so basically everything that you can do with CDK for Terraform, and Sebastian showed some examples of that, can be also done with Wing. And so if your company has a bunch of Terraform modules that are best practice modules for your cloud applications, then you can basically define them in your Wing application as first-class citizens. I think the other side could be a bit more involved, but still possible with custom platforms. And so if for example, in your company, you have a module that represents a bucket or an object store, and Terraform module, and that's how you want to implement cloud buckets with, then you can use custom platforms in order to codify that implementation. And so the custom platform would say, anytime an application requests a new bucket, then use this Terraform module as your backing implementation. And so that's completely possible to do. We've actually heard that from multiple companies that we talked to, that they use Terraform modules as a way to codify best practices across teams. And so maybe we'll have some more first-class support for that. But technically, using custom platforms, you should be able to completely control how your output looks like. And so in that sense, it's supposed to be supported.
Thank you. What about using the pre-flight API and the in-flight code? For example, when your in-flight code would create another bucket or another infrastructure.
So that's not supported right now. It's an interesting use case. Some people say it's probably not the best practice to provision infrastructure in flight in a way, but there are definitely, I am familiar with a lot of use cases for that. So it's not like, for example, if you're building a multi-tenant application and you need to provision infrastructure for customers, then you would find yourself needing to actually provision infrastructure. So there's a lot of heavy machinery required to do that. Being able to actually provision resources means that your in-flight code needs administrative permissions on your cloud account. So it's not supported as a first-class citizen in a way, but technically it's possible, right? Like you can technically run Terraform from Lambda functions or from containers. And maybe at some point we'll have more first-class support for this, so you can actually write your Wing pre-flight code inside in-flight code. That could be really interesting to explore. But currently, pre-flight code produces Terraform file. And so once you produce the Terraform file, you can go and deploy it. But it's not like, I think we need to do more work to make this a really good experience.
Awesome, thank you. I think we burned through all our questions, and I guess it's time. Oh, there's another question. Sorry about that. Can LocalStack provide a standalone S3 container to replace MinIO?
Oh, yes, I love that question. So we, in fact, have done quite some work on a new S3 provider recently, and we also put measures in place to create and bundle images with just single services. In fact, S3 is one of those cases where we're looking to get out just an S3 image with a very stripped down size, like very small and lightweight, which then, again, potentially could replace something like Minnow or be like an alternative to that. So again, it's one of the things. We do have some plans for our V3 release coming up in a couple of weeks, so stay tuned. And I think this is also going to be part of what we're going to put out there. Yeah.
Awesome, thanks. Now I really think we don't have any more questions. My colleagues in the background are pulling the ropes, so yeah, I guess we can wrap it up unless anybody else has anything extra to say. Okay, thank you so much for joining, and thank you for your presentations. It was very insightful and interesting, and I'm really looking forward to explore more. And I hope to see you more often in our meetups.
Thank you, Anka.
Thank
Thanks
you so
for
much.
having us. It was great. The demo guys were with us. That was great.
Have a good day.
See you all. Bye. Thank you.
Bye.
Bye. See you later.